let's continue with our part two of our IPsec tunnel. So in the first video, we've gone through a bit of an update on how the packet looks like when the encapsulation happens, when the authentication header gets added. In this video, I want to talk more around the IKE phases. We got our internet key exchange, which obviously helps us with our key management and key exchanging. I want to cover basically how it does that and what the two different types of IKE phases look like. So basically, when we're implementing VPN networks between two different gateways, the primary and common protocols to support that is obviously IPsec. So that's how we go away and do that. Now, meaning the overall area is that two firewalls. In this case, we've got firewall one, firewall two. These two firewalls are going to obviously become best friends, and we want them to be best friends on how they communicate, how they handle the data, how they handle the interactions. And I'm just going to do two tunnels here because as we start talking about two different IKE phases. Each of those are going to be representing different bits of traffic. Now, the traffic that's going between the two different networks, we want that to be protected, right? That's what the whole area is of IPsec. It's protecting our data, the confidentiality, and obviously the integrity of that data. So as the data goes through the tunnels, it's protected as it exchanges or traverses through the internet. Now, in the background, basically, as all this happens, it's something called the internet key exchange. So I'm going to put here IKE. So IKE is something that's very common. It's been around for yonks, and that's our internet key exchange. And this is all about how authentication happens with our tunnels, right? So we've got IKE version 1. So I'm going to put a version 1 and a version 2 here because it's two different versions, and I'll talk about what they are. And the main benefit of IKE is basically automation and negotiation that happens dynamically. I'll emphasize the word dynamic because uh, it happens dynamically, and I'll explain how it does that in a moment. So, and basically, it's as it begins to negotiate, it dynamically learns everything, how it authenticates, and between obviously the two gateways that we're going to have, and then it builds and maintains and establishes those connections, right? So the connection of our phase one here and maybe a phase two, which we'll talk about. So now with IKE, we build two tunnels essentially, right? We got our IPsec tunnel to support our connectivity between the two hosts. So we'll have our IKE phase one, and IKE phase one is just purely about the two devices communicating against each other. So this I'll put here as our IKE phase one. So this is just these two firewalls talking to each other and remaining, knowing who they are and what they're all about at all times, right? So that's phase one. Then phase two, I'll get my red pen here. Phase two is where, let me just write this out. Like phase two is predominantly where all our traffic will go, right? This is all our data traffic. And then obviously they'll go away, put IKE phase one, and then IKE phase two, or the tunnel two, then is our IPsec traffic essentially. So that's how it happens. So now, if these two gateways need to have a tunnel, and obviously they don't like or they don't know if they should use IKE version one, well, then they're going to have to establish what they're going to use, right? So phase one is all about the tunnels and how they're going to negotiate. And there's 5 simple things they're going to do this by, right? And the easy way to remember this, and if I write it over here, because I'm going to do it in 2 different colors. So the red is going to be our IKE phase 2. I'm going to put IKE phase 2, and this is how they're going to negotiate. And I'll just draw a line down the middle in a neutral color so we can separate it so we can see the difference. And the purple over here will be our IKE phase 1. All right, and it does this very simply with a couple of things, and this is probably the easiest way to remember this, right? And this goes by haggle. Now, if you're not sure what haggle is, we're going to explain it, right? So the first way that it negotiates its authentication. So it's going to go away. So the two gateways need to obviously form a level of trust. They need to establish phase one before phase two gets established and have to negotiate, and they're going to haggle between each other, right? So kind of think of it in a form where they're going to fight, and I'll kind of review the fighting scenario because they're going to haggle with each other. They're going to say, well, show me what hashing you're using, what authentication, what Diffie-Hellman group. It's going to be that aggressive communication. That's what haggle is, right? So first part of that is it's going to verify, wants to verify part of that negotiation process. Remember, we want to go, okay, well, are we going to use hashing? So we need to verify the data integrity is in transit. So we're going to say, well, what sort of hashing are you going to use? And that's the first form. The next form is authenticate. So authentication. So how are we going to authenticate with each other? Is that through, I'll just write authenticate. Is this through maybe digital certificates that we've spoken about? Is this maybe a pre-shared key that we're going to go onto these firewalls and configure a pre-shared key that they're going to know about, right? It could be one, could be the other. The other one there is our Diffie-Hellman group. So I'm just going to say, so group, um, and this is our Diffie-Hellman group. And I'll talk about perfect forward secrecy in just a moment. So, but our Diffie-Hellman group basically allows, it's basically the protocol that allows these two peers to dynamically set up and negotiate the keys to lock and unlock the data, right? So that's what Diffie-Hellman will do. And there's different forms of groups. Basically, they'll need to agree on what group or what algorithm they're going to encrypt and decrypt the data on. So the Diffie-Hellman group will have to be negotiated. So we have to define what that Diffie-Hellman group is. We also have to define the lifetime. How long are these two firewalls going to stay up for? Is this going to be a 1 year relationship? Is this going to be a 6 year relationship? Or is this going to be, a smaller time frame? Is this going to be 6 months? The lifetime is all about how long are we going to keep our adjacency per se with each other. And finally, the last part is E. This is encryption. What encryption standard are we going to use? Is it going to be AES? Are we going to sit on 256? Are we going to sit on 128? What is it? And that's one form, right? So one part of the tunnel has to get authenticated. So we're going to build our tunnel up first. And then from there, once they've agreed on what they're going to run, and obviously we're going to go in there and administer the firewall. So we're going to put it in, it'll go away. They'll create the keys and establish essentially phase one. So phase one is now, if we've agreed on what protocols we're running, phase one has now been established. So, okay, so now the two firewalls can communicate. They know who they are. They know what permissions and settings they're running, and they've negotiated, they've haggled with each other to negotiate the protocols. Now, phase two um, is basically where it's going to protect the user traffic. So phase two is our IPsec tunnel, and it's all about our user traffic. And it sort of goes through the same process, right? So using that security from the IKE phase one tunnel, they'll do the same thing and they'll haggle again between each other for IKE phase two, which is our IPsec tunnel. And think of this is our data of our traffic of our users or user traffic, right? So the same sort of process will kind of happen here. Now we've got our H. We're not going to authenticate, but we are going to do our Diffie-Hellman group. We are also going to look at our lifetime and obviously our encryption. So everything just purely apart from the authentication part. Now, same thing as hashing. So we can use the same form of hashing as we use in Form 1, or it can be different. So we can use MD5, we can use secure hashing algorithm. We can use 256 for SHA, whatever flavor of SHA we want to use. It can be the same or they can be different. It doesn't really matter. So that's hashing. The next component that we'll need to do is, well, we need to define our group. Now, our Diffie-Hellman. Again, so Diffie-Hellman is everything from basically the protocol that allows the peers, in this case, the two firewalls, to dynamically set up and negotiate the keys. That's going to go away and unlock and lock the data. So unlock and lock the data. So it's the algorithm that allows us to do that. That's Diffie-Hellman. And there's different groups and flavors of that. I'm not going to discuss it in this video, but that's what it traditionally is to do. Now, the Diffie-Hellman group. Now, if we enable Diffie-Hellman group again to run, we're going to enable perfect forward secrecy. And this is basically us saying, well, we're using good hygiene, that we're not recycling the Diffie-Hellman group that we're using in phase one. So it's more better that we use maybe another Diffie-Hellman group, and it can then be required onto how we want that setup to look. So we'll go away and we can set it up if that's the way we want to, or if we're not. If we want to enable perfect forward secrecy, that's great. It just means that we're now running a different Diffie-Hellman group than we did in our phase one. So it can be the same if you want it, or we can go away and do our own, do it again. So if we do it again, just know that perfect forward secrecy will be enabled, which is a nice thing. Lifetime would be the next thing. So again, how long do we want this lifetime relationship to be enabled for? And then finally, encryption. And then once we go away, we define our encryption. Again, it could be different. So if we're using maybe, let's say we're going to use AES 128, here we can use 256 for our encryption on our IKE phase one. Doesn't need to be the same, it can be different. So that's how phase one and phase two establish communications. And then should all that go hunky-dory and we've configured everything nicely, then my friends, phase two is enabled. I hope you've enjoyed this video as we've discussed IKE phase one and IKE phase two across the IPsec tunnel. And as always, I hope you've enjoyed this video. If there's any other comments or feedback you'd like to see with our IPsec tunnel, please let me know. And as always, see you all in the next video. Bye for now.